Hi everyone. I want to go over an example using my chalkboard here of all the measures of central tendency and variability that we went through in those presentations that I posted here. Okay, so this is kind of a live example as if we were in class. Okay, so I got to look down at my chalkboard to do this for you guys. Okay, so let's say that I have pulled five um, students from the class, and I asked them to tell me how many hours per week that they have spent studying for this class. All right, so let's say that one student said they studied 3 hours, another one said 5 hours, one student said 0, one said 4 hours, one said 3 hours. Now, I'm not suggesting that any of these are recommended numbers of hours to study. Certainly not 0. Okay, so let's go through just about everything that we know how to do here. All right, so one of the first things that we covered was the mode, measures of central tendency. All right, so what is the most frequent occurring score in this data set? I think you can easily see that that is 3. So the mode number of hours studied is 3. All right, let's put that over here. Okay. The next measure of central tendency is the median. And to calculate the median, I need to first sort the data. So let's do it like this. There's a 0. There's 2 3s. There is a 4 and a 5. Okay, and so the middlemost score, now that we've sorted them, is a tricky one here. All right? Seemingly tricky one. Okay? It's a 3, but I have a repeating 3 in the middle here. Do I need to worry about that? The answer is no. You only have to do that bizarre case 3 median when you have a repeating number and an even number of numbers. We have an odd number of numbers, 5 numbers, and so the answer is the number we're pointing to right there in the middle, 3. So my median is also 3. Okay? All right, let's get the mean. To get the mean, and let's do it like this. This is a sample, so x bar will be my answer. All right, the mean, the formula for calculating that mean is, again, add up all of the scores and divide by the number of them, all right? So let's do this. It's time to add up those x's, all right? So the sum of x is equal to 3 plus 5 is 8 plus 4 is 12 plus 3 is 15, all right? So you should use a calculator whenever you need to, okay? I did that one quickly, but you should use a calculator. Don't ever be ashamed to use a calculator. Okay, so those add up to 15. So the sum of x is 15. N is the number of data points in my data set. I have 5. So 15 divided by 5, again, I'm not going to pull out the calculator for that, is 3.00. Okay, so the mean is also 3. We've got a nice symmetrical data set here because the mean, the median, and the mode are all 3, all right? When they all line up like that, you know that you have kind of a symmetrical data set, all right? So, all right. Okay, so those are my measures of central tendency, mean, median, mode. And they all equal 3. So now let's move on to the measures of variability. And the first one that we encountered was the range. And the range is just simply the highest value minus the lowest value. So my highest value is a 5, my lowest value is a 0, and so 5 minus 0 is 5. I have a range of 5 hours of variability in studying for this class. All right, I'm not going to do the interquartile range. I promised you we wouldn't be doing that, and you certainly wouldn't do that with 5 numbers. Shave off the upper and the lower 25%. We'd be left with less than 3 numbers. Okay, so we skip the IQR, and let's now go through those measures, the rest of the measures of variability in a sequence. Okay, so just to repeat what I did there, I had gone through the whole process, the concept. I wanted you to understand that the next number that we want to get is, we'd like to know on average how much people differ from this mean number of hours of studying of 3, right? Because all 3 of these measures of central tendency, and particularly the mean, are telling us that on average students study 3 hours per week. Okay, so everybody differs from 3 by some amount, and we'd like to know, well, what's the average amount that the scores differ from 3? In other words, people differ from 3 by an average of how much? Okay, so we need to know how much they differ. So one of the next things we need to get are little x's, okay, deviation scores. All right, so we're going to get a few more values here, so let's make some room. All right, I need the deviation scores. Now remember that a deviation score is equal to a big X minus its mean. Okay, so 3 minus the mean of 3 is 0, right? So the first person differs from the mean of 3 by 0. Okay, the second person studies 5 hours. They study 2 more hours than the mean, right? 5 minus 3 is 2. Okay, now I'm going to do something that we don't normally do here just to beat the obvious home. All right, so I just want to make sure that it makes a difference now, because some of these are going to be positive numbers and some of these are going to be negative. So let me go ahead, and I don't typically do this, but let me put the pesky plus and minus signs up there. All right, poor student number 3 didn't study at all, and so they studied 3 hours less than the mean, right? And 4 hours is 1 more than the mean. 4 minus 3 is not 3. 4 minus 3 is 1. Okay, and lastly, the last person varied from the mean by, again, 0. Okay, all right. So the next thing I want to do is I'd like to know what the average deviation is. Okay, so let's call that that's not to be confused with my big X bar. This is little x bar, and so I need to add up those deviations and divide by the number of them. Okay, so I need to add these up. Now notice I'm trying to be consistent with using big X's and little x's. Okay, this one over here is kind of is a little bit too big, but anyway, let's add those up. All right, 0 plus 2 0 plus 2 minus 3 is negative 1, plus 1 is 0, plus 0 equals 0. All right, so whoops, that equals 0. Okay, now remember that's supposed to be, so that was a check of our work. The sum of the deviations must always equal 0. If they don't add up to 0, you've done something wrong. Maybe you calculated the mean wrong. Maybe you calculated one of the deviations wrong. So everything else you do would be wrong. So even though we're not going to use this, because look, the sum of those is always going to be equal to 0. 0 divided by anything is 0, and that's not a very helpful number to us. Okay, so we don't use that, and so I'm going to erase it. All right, so now you saw me do it, but I need the room. Okay, so this was a check of our work, and we confirmed that the sum of the deviations is 0. Okay, so the next solution that I had suggested to you all was to take that. Oops, to take the absolute deviations, okay? So one way to get rid of the pesky plus and minus signs, because they're the ones that made this all add up to 0, was to just get rid of them, okay? So these now are absolute numbers, so we just get rid of the signs and no pluses and minuses. And so we're on our way to calculating what I'm going to call, what I'm going to call absolute x bar, all right? And absolute x bar is again equal to add up those absolute little x's divided by the number of them. All right, so let's get those. Let's get the sum of the absolute x's. So 0 plus 2 plus 3 is 5 plus 1 is 6. Okay, plug that into this formula down here. Those add up to 6 divided by 5. And we pull out our calculator and tappity tap tap, and that is equal to 1.20. Okay, so voila, we have a what I call the MAD, the mean absolute deviation. Okay, absolute little x bar is what I call the MAD, and it equals 1.20. All right, so what does that mean? It means that on average a student studies 3 hours per week for the class, and they tend to differ by that amount by about 1.2 hours. Okay, so an hour, 1.2 hours. Okay, but as I told you, we don't ever use the MAD. Okay, so that's again kind of a dead end. And so we need to continue on. So again, we're back to the pesky plus and minus signs screwing us over. We don't use absoluting, is that a word, for fixing this. So the solution that we've settled upon is to square those deviations. Okay, so I'm going to create a new column of squared little x's. Those are little x's. Okay, so back to the originals here. So I'm going to square each one. So and notice I'm not squaring the big x's. I'm not squaring the raw data, the raw numbers, all right? I'm squaring the little x's, the deviations, all right? So the deviation of 0 squared is 0. 2 squared is 4. Negative 3 squared is 9. Everything becomes positive. That's why we're doing this. We're getting rid of negatives, okay? And 1 squared is 1, and again, 0 squared is 0, okay? So I'm quickly running out of room here. So I had calculated a MAD, and I forgot to write it over here. That was equal to 1.20. I'm now about to calculate what I wanted to call the SAD, but you remember I can't call it the SAD. I have to call it the variance. Okay, so I'm going to use symbols now. The variance is equal to S squared, and I need to calculate S squared now. Okay, so I need some room. I'm going to erase that MAD. I get mad having to erase the MAD. And then I get sad that I don't get to use that. All right. So now I'm calculating S squared. And my formula for S squared is I have to add up all of those squared deviations and divide by the number of them. All right. So let's get that. The sum of the squared deviations will be, let's add those up. 1 plus 9 is 10, plus 4 is 14, plus a couple of zeros is 14. All right, the squared deviations add up to 14. So let's plug that in here. 14 divided by 5 numbers. Okay, so 14 divided by 5, you pull out your calculator and tappity tap tap tap. By my estimation, 14 divided by 5 is 2.80. Okay, so 2.80, that's not very good. Okay, 2.80 is my variance. Okay, now remember the variance isn't a very good descriptive statistic because we squared those numbers. Now with small numbers and a small number of small numbers, the variance isn't so obviously screwy. Okay, these some other examples that we've gone through, the variance is obviously visually screwy. It's too big of a number to be useful as a descriptive statistic telling me how much these scores differ. So ignore the fact that these are, this isn't totally screwy here, but it is. Okay, the numbers are squared, so the variance is not a good solution. So the last thing almost the last thing I want to do is calculate just plain old S. That doesn't look good. Okay, so now I want to calculate what we call the standard deviation. Okay, I need more room, so let me do some more erasing. All right, so you see how I got this. Let me erase my work here for the variance. And I kind of wish I kept it, but I didn't. All right. So I'm calculating S now, and S is equal to the same formula as the variance. So put that right back where it was. We add up the squared deviations and divide by the number of them, but we have to take the square root of that whole thing. So don't forget that. All right. So we already did some of this work. So those added up to 14. It was 14 divided by 5 again, but don't forget we're taking the square root of that now. Okay, and that was equal to 2.80, but we're taking the square root of that, so I could have just started from here. All right, so the square root of 2.8 is, plug that into your calculator, and it's I will do that for us. 2.8 square root of that is, on my calculator, it's 1.67332. All right, I'm going to round this to 2 decimal places because I had whole numbers that I started with, and so that rounds to 1.67. All right, now to be consistent with something I told you earlier, I'm going to change my equal sign to and approximately, my squiggly equals 2, all right? So this tells you and me and other people familiar that we've done some rounding here. 1.67332 rounded down to 1.67. So 1.67 is my standard deviation, okay? Now what does that mean? What does that mean? Again, this sample suggests to us that students study on average 3 hours per week for the class, and they kind of differ by a mean of about 1.67 from that mean. All right, they differ by 1.67. I always say kind of on average, sort of on average. It represents the average. See, remember, because we squared and now we're unsquaring. So it represents the mean amount that the students differ from their mean of 3 hours. Okay. Another way to say it is that the students differ sort of on average from each other by about 1.67. The average amount that the scores differ from each other was 1.67. Okay, so the standard deviation is nothing really magical. It's just another kind of average. You've been familiar with the average since you were a little kid. And so it's now just kind of another average. It's now the average of not the raw scores, but the deviations, how they deviate from their mean. Okay? So there's one more thing that I have that I taught you, and that is a warning about small samples. 5 people is definitely a small sample. So if I want to use these 5 people to estimate some bigger population of students, I have to be very nervous about using just 5 people, and I hope that intuitively feels kind of risky to you. Okay? So remember that when you use a small sample to estimate a population standard deviation, it tends to be too small. So we need to correct it. We want to jack it up a little bit. All right? So I want to calculate what we call S hat now. Okay? S hat is a estimate of a population standard deviation from a sample. All right? I'll say it another way. It's using a sample to estimate the population standard deviation. And my formula from that is very similar. Okay? instead of just n down in the basement, I got to put my hat on top of my s. That's very good. Let me try that again. That's slightly better. All right, s hat is equal to not just n, but n minus 1 in the bottom. All right, so we're gonna wind up with something slightly different here. So put the same 14 up top, but now we're dividing by 4, right? And don't forget the square root symbol. All right, so now it's 14 divided by 4 instead of 5. 14 divided by 4 is, here's a little trick I do to help, suggestion to help you remember. Many students often forget that square rooting. So do it first. Put that in first. You might forget to put it in afterwards. So get in the habit of putting it in there first. All right? So 14 divided by 4 is 3.50. Okay? And the square root of 3.5 is approximately equal to 1.87. So put that right there, right next to it. Okay, so there we've done everything we know how to do. We calculated the mode, the median, the mean, the range, the MAD, the variance, the regular sample standard deviation, in other words the standard deviation for those 5 people. And then we use those 5 people to estimate what some larger group of students, how they differ from each other and from their mean. Okay, and you see it's a little bit bigger. This S hat it bumped it up from 1.67 up to 1.87. Okay, so again, what does that mean? That's now an estimate of what we're projecting that the population of students, so students in this class would study an average of 3 hours. And we never have to, we don't have to do some kind of similar adjustment to the mean. The mean is a really stable thing, even with small samples. So notice we didn't have to do any kind of funky adjustment of the mean. We kind of trust, even for small samples, that the mean is going to be hopefully not too bad, all right? So, of course, it could vary, but our best guess right now is that the mean is 3, and that students differ from 3 hours by about 1.87 hours. All right, so that's S hat. Okay, so there you have it. The measures of central tendency and the measures of variability. All right, central tendency, measures of variability. I hope that another example of walking through that all helped a little bit. Sorry it didn't all fit on my whiteboard, and I think you should practice these. So do a couple of the examples over again yourself. Make sure you get the same answers I do. It's like riding a bike, okay? I make it look easy, but you need to get on the bike and try it out so that on test time, you're not wobbling, all right? So remember on your tests are always a timed kind of thing, all right? You always have a limited amount of time, and that's not when you should be learning and practicing, all right? I want you to practice before you come to test. Ride the bike before you go to class, all right? Before you go to the test, all right? Try some of the examples that are in your chapter in the book. And the answers, some of the answers are in the back of your book, and make up your own examples, all right? So practice, do several before you come to the test time, all right? So I hope that helped. Thanks for your attention. Do definitely contact me if any of this is still mysterious or you need help or assistance with this, okay? All right, good luck.